Today we will discuss about wheat stone bridge. Consider four resistances. P, Q, R, S. Make a bridge. Let us have another resistance G. It is a galvanometer. Give a current I. We will give some battery. Okay. Let us say I current is flowing. Let us divide this current I here using Kirchhoff's current law. Let us say this is I1. Let us say this is I2. This I1 again gets deflected, divided. Galvanometer draws its own current Ig, and the remaining current will pass from this branch. Ig current is coming, I2 current is coming. So it will pass through S. So this is I1, I2, Ig, I1 minus Ig, I2 and I2 plus Ig. Now use Kirchhoff's voltage law. Let us have this loop A, B, C, D. So I am having a loop A, B, D, A. Okay. So loop A, B, D, A. No EMF in this loop. So this is 0. Okay. Current is moving in the direction of loop. So current into resistance is positive. So this is resistance into current is positive. Current is moving in this direction. Loop is moving in this direction. Both are in the same direction. So G into Ig, R into I is also positive. Loop is moving in this direction from D to A, but the current is going from A to D. So the direction of the current is opposite to that of the loop. This is the loop, this is the direction of current, this is opposite. So this is minus Ri2. Let us say this is equation number 1. Consider second loop. Let us say this loop. Let us say B, C, D, B. B, C, D, B. Again, there is no EMF in the circuit. So left hand side is equal to 0. The direction of loop and the direction of current is same. So current into resistance is positive. So this is Q I1 minus Ig. Current is moving in this direction. Current is moving in this direction. Loop is moving in this direction. So this is negative. So minus S I2 plus Ig. Loop is moving in upward direction. Current is in downward direction. So this is minus Gig. This is equation number 2. Balanced wheat-stone bridge. It is that bridge in which the potential at B is equal to potential at D. When potential at B is equal to potential at D, so VB minus VD is equal to 0. It means Gig is equal to 0. It means Ig current will be 0. Galvanometer resistance cannot be 0. It has certain value. So Ig will be equal to 0. So put the value of Ig equal to 0 in equation 1 and 2. You will get Pi1 minus Ri2 equals to 0, or Pi1 is equal to Ri2, and in equation 2 Qi1 minus Si2 is equal to 0. So this is QI1 is equal to SI2. Divide them. So this will be P upon Q is equal to R upon S. So this is the equation of balanced Wheatstone bridge. Now we will discuss, next lecture is meter bridge or slide wire bridge. Meter bridge, or we also call it as slide wire bridge. You have 4 resistances in Wheatstone bridge. That's principle, balancing of Wheatstone bridge. Here we are going to use, means the principle of meter bridge is balanced Wheatstone bridge. So we had 4 resistances, okay, and what are these? These are connecting wires. We will use strips instead of wires. Why strips? Because resistance is inversely proportional to area. If we increase the area, resistance is small. So for meter bridge, this is a strip, this is the strip, and again this is the strip. Here one thing we have to keep in mind, that we will make it a 1 meter long for ease of calculations. Here we will have a nichrome or constantan wire. For what? For R and S resistance. Second R and S. We have considered wire which has length of 100 centimeter, and we will mark here a galvanometer with a jockey. Jockey is used to have connections where we can slide jockey on this wire, and we will find a null point. What do you mean by null point? Null point means a point where the galvanometer shows null deflection. Yes, definitely we have to give energy. We will give a battery or a cell, a key. Current is flowing in this circuit. Here is a one circuit, here is a one resistance P, and here is another resistance Q. Okay, you can have any one of them as unknown. Let us say I have an unknown resistance of P. Even I can have a wire. Okay, I can have a wire. Take its length again 1 meter for ease of calculations. You just move galvanometer from this point to this point. Select a resistance from this resistance box, 5 ohm, 10 ohm, whatever is the value. Obtain a null deflection. This is, let us say, length L. This is 100 minus L. Naturally, if it is L, 100 centimeter is the length, this part will be 100 minus L. R is directly proportional to L. S directly proportional to 100 minus L. So R upon S is equal to L upon 100 minus S. We get R upon S. And here it is P. Let us say it is X. So also we have X upon Q. We have the formula P upon Q is equal to R upon S. X upon Q is equal to L upon 100 minus L. So X value can be calculated by using meter bridge. Okay. From here we can obtain the unknown resistance. If you know the resistance of a wire, if you calculate its diameter, you can calculate its area. You can find out the resistivity, because R is equal to rho L by A. So you can calculate resistivity. So meter bridge can measure what? Resistance of unknown wire, its resistivity. And also we can use what? We can use it for unknown temperature also. You can find out the value find out the value of resistance at different temperatures, and then you can compare, and you can also find out the temperature. Okay, next is potentiometer. Potentiometer is a device. Potentiometer is a device which is used to measure the internal resistance of the cell. In meter bridge we have used 100 centimeter wire. Here we are going to use a 400 centimeter wire. Definitely we are going to give energy. Okay, ammeter is given, key is given, rheostat is given, and connect it here. So it is apparatus which is again in length of 400 centimeter, 100, 100, 100 and 100, total length 400. It is placed on a 100 meter long card. Okay, so what is principle of potentiometer? It is based on the principle of potential gradient. Means this EMF is divided equally across the length of this wire. We know that E is equal to IR, potential difference is equal to current into resistance, R rho L by A. If area is constant, resistivity is constant, current is constant, then E is direct proportional to L. So E upon L is equal to constant. So this is the principle of the potentiometer. Means it is based on the principle of potential gradient. We have two applications of it. First application is to measure internal resistance. To measure internal resistance. किसकी internal resistance? Internal resistance of cell. That is very difficult. Let us have a cell. If it is negative, it is positive. If it is negative, then here negative is to be considered. Let us say this is EMF E1. This is giving current. This is not giving current. Also have a known resistance. Have a key in the circuit and mark a galvanometer. Let us say this is the EMF of the cell. When this circuit is open, means key is not inserted, then find out null deflection, means 0 in the galvanometer. Definitely it will give EMF, the value of EMF, because circuit is open. It is not giving current. Current is given by this EMF, that we have considered a large value of EMF here, and it is a small EMF. We have to do it. Okay, so in this case E is direct proportional to L. When I am going to insert key in it, what will happen? The current will draw in this circuit. The current will be consumed by this resistance. Definitely current will flow from cell. So internal resistance, what will happen to the internal resistance? There is a potential drop. So that potential drop will lead to the terminal potential difference. Definitely the length will be reduced. Let us say that is L1. So this is now terminal potential difference. E upon V is equal to L1 by L2. We know the formula, E upon V minus 1 into R. So what's the problem? So we can calculate L1 by L2 minus 1 into R. Simple. When key is open, obtain length L. Okay. Oh, sorry. Let us say this is L1. Let us say this is L2. for easy calculation, sorry, for easy calculation, let us say this is L1, let us say this is L2. So when circuit is open, length is L1. When circuit is closed, length is L2. When circuit is open, it is EMF. When circuit is closed, it is potential difference. Divide them. We have compared the length, put in the equation. So we will get the what? Internal resistance of the cell. Let us have its second application. And the second application is to compare the EMF of two cells. You can consider Leclanche cell, another Daniel cell. Okay, so I have two EMFs. Let us say it is E. Let us say it is E1, E2. Okay, there are two cells. Even you can purchase cells from the market. A3, A4, the pencil cell, or you know, pencils are available in different sizes. A3. Okay, so when I connect this circuit, definitely EMF of this circuit will be obtained by, let us say, the length L1. So E1 will be directly proportional to L1. And if I break this circuit and connect it with it, then the length will be obtained corresponding to this E2. And let us say the length is L2. Obviously it will not be same, because EMF of two cells cannot be same, may not be same. So this will be L2. So this is the comparison of two cells. So this is the comparison of two cells. So we have obtained here EMF of two cells by dividing them. Once we will get the ratio of lengths, then definitely we are going to compare the EMF of cells. So meter bridge is based, let us discuss again. Wheatstone bridge is based on the principle of Kirchhoff's laws. We obtained balanced Wheatstone by putting Ig is equal to 0. Okay. Meter bridge based on the principle of balanced Wheatstone bridge. Potentiometer based on the principle of what? Potential gradient. It has two applications. What? To find the EMF of to find the internal resistance of the cell, and to compare the EMF of cells. Thank you.